Hello, welcome to Chapter 5.3, Part 2, Adding and Subtracting Rational Expressions with Different Denominators. Things become a bit more difficult or perhaps complicated when we are adding and subtracting with different denominators. Here, we have to look for the least common denominator or the lowest common denominator. As we learned earlier, that's the set of denominators is the smallest expression that is divisible by each of the denominators. Or that's the more formal definition. We've done this before, so I'm just going to go through this real quickly. So we're going to factor the denominator of each rational expression. We're going to find the lowest common denominator of all the rational expressions. Then we're going to rewrite each rational expression as an equivalent one with the lowest common denominator as the denominator, and add or subtract the numerators and write the result over the lowest common denominator. Then finally, of course, simplify the rational expression if possible. So I'm going to work through just a regular fraction using these steps. For the first step, I factor out 12 and I factor 15, and I find that the lowest common denominator, I have 2 squared, that's the highest 2, I have 1 3, and then I have, well, that's only 1 3, I have 5, and then so it turns out that the lowest common denominator is 16. Then I'm going to change it now to equivalent fractions. So here I have the first one, where I have 3 over 12, I have to multiply that by 5 over 5 to get 15 over 60. And then the other term I do similarly, but with 4 over 4. And so now both of them have the same common denominator. So now we add them together. So here we have 15 over 60 plus 24 over 60, and now we add the numerators together to get 39 over 60. And then we reduce to lowest terms. So in this case, it turns out that both 39 and 60 are divisible by 3, so we end up with 13 over 20. In example number 5, we're asked to add these two terms. And if you notice, the denominators are different, so we can't just add them up. So here, like earlier in the instructions, I wrote we first want to factor and find the lowest common denominators. So in order to find the lowest common denominator of these two, we have to factor them. So I factor x squared plus 2x minus 3, and here I get x plus 3, x minus 1, and then I factor x squared minus 9, which is the difference of 2 squares, and then I see, well, they each have x squared plus 3, and to the first power, that's the highest power, there's only one x minus 3, and then there's the x minus 1. So this is our lowest common denominator. Then we want to change each rational expression into an equivalent expression, and we do that by putting this onto the denominator. So here we do that. So as you see, this is the denominator, and we have to multiply the numerator by what's missing from the lowest common denominator. In this term, we see that what's missing is the x minus 3, so I have to take the negative 2 and multiply it by the x minus 3, and here I have my lowest common denominator with my new numerator. Similarly for the next term, where what's missing is the x minus 2 from our lowest common denominator. And then, of course, I use my distributive law, and I get 3x minus 3. And now both of the terms have the same denominator, so now we can start combining them. So here we have it. So here we have this term and this term, and then we combine them because we have negative 2x plus 6 and 3x minus 3, so negative 2x plus 3x is x, and then plus 6 minus 3 is 3. So here, and this becomes our final answer but not quite, because we can still do a little bit of reducing or a little bit of simplification, and we see that x plus 3 cancel out to give us a 1 on top, and so we end up with 1 over, remember that 1, over x minus 3, x minus 1. In example 6, we're asked to subtract these two terms. So let us go over to the whiteboard and work this one out. So here in example 6, we have the problem or example x plus 4 over 2x plus 10 minus 5 over x squared minus 25. So what we're going to do first here is we're going to look for the lowest common denominator. So here we're going to look for the lowest common denominator. And so in order to do that, we'll look at first, we're going to factor 2x plus 10, and we see that that's equal to 2 times x plus 5. And then in the other factor, we have other denominator here. We have x squared minus 25, and we see that's the difference of two squares. So that's just equal to x plus 5, x minus 5. So remember, in order to find the lowest common denominator, we have to look for the highest power of each of the terms. So here we only have 1, 2. So we put the 2 here. There's no 2 down here. And here we have an x plus 5. And here we have an x plus 5. But we only have 1. And the highest power is to the first power. So that's x plus 5. And then we have only one x minus 5. So we have x minus 5. So this is equal to our lowest common denominator. Now we have our lowest common denominator here. So that is 2x plus 5, x minus 5. And now we look at the numerator in the first term, and we want to look at the denominator here, and we want to see, well, what is missing from this denominator? And we look back and we see that what's here but not here is the x minus 5. So we have to take the x plus 4 and multiply it by the x minus 5, and then the next term we do the same thing. So we look at the denominator here, and this is the one with the difference of the two squares. So we see the only thing that's missing here that is over here is the 2. So it's going to be 2 times 5. So now we want to simplify the numerator as much as possible. So let's look. We want to now use the distributive property to solve that, and we want to combine them. So when we do that, we get x. So here we have top is x squared minus 5x plus 4x, and then plus 4 times negative 5 is minus 20, and then here 2 times negative 5 is negative 10. And that's all over 2 times x plus 5, x minus 5. And now we want to take this out of the brackets and combine it further. So we have x squared minus x, and minus 20 and minus 10 is minus 30 on the top. And that will be over 2 times x plus 5 times x minus 5. And now we want to factor the top to see if we can simplify it even further. And it turns out when we factor it, we get x minus 6 times x plus 5 all over 2 times x plus 5 times x minus 5. And we see that the x plus 5s cancel out, so we're left with x minus 6 over 2 times x minus 5. And we can, that's as simple as I'm going to make it for now. We don't have to multiply the two, and you don't have to. If you want to, you could write x minus 6 over 2x minus 10, but it doesn't really make that much difference. So going back to the PowerPoint in example number 6, we have, and there I did it, okay, so now I found the lowest common denominator here, just like I did on the whiteboard, and then I used the lowest common denominator to combine them, and then finally I combined them because I made sure that they had the same denominator. And then I factored the numerator to see if I could cancel anything. Remember, I don't want to kill any kittens. And indeed I did. So then I ended up with this. And I could use distributive property to take this out of this form. But I might as well leave it there because, as I said on the whiteboard, it's not going to make any difference. Now we're going to subtract in example number 7, these two. And as you notice, again, we have a couple of trinomials. They're different trinomials in the denominator. And again, I'll work it out on the whiteboard first, and then we will look back at the PowerPoint. Now, in example number 7, we have something a bit more complicated. We have 2x minus 2 all over x squared plus 4x plus 3, and that's minus x minus 1 all over x squared plus 5x plus 6. So let's look at this, and we see that in order to find the lowest common denominator, and I should note that the lowest common denominator is the same thing that we've also called the greatest common multiple. So we're going to do that same process, the process as we have done earlier and we've done in other things. So we have the lowest common denominator, which we call the greatest common multiple. And we look at each of these, the denominators of each of these terms, and we're going to factor them. 2x squared plus 4x plus 3. And when we factor that, we get x plus 1, and we get x plus 3. And then for the other term, we have x squared plus 5x plus 6. And when we factor that, we get x plus 2 and x plus 3. So now we can look for what the lowest common denominator is. So we look here and we have x plus 1, x plus 3. And we look at this, the next denominator, and we have x plus 2, which we don't have yet. And then we have x plus 3, but we already have x plus 3, and the highest power on both of them is 1, so that is our lowest common denominator. So now I'll put it down here, x plus 1, x plus 2, x plus 3. So there it is. There's our lowest common denominator. So now we're going to combine it into one fraction. But in order to do this, we have to take the first term and we have to multiply by whatever's missing from here, the denominator of the first term that we have here. And it looks like we have x plus 1, x plus 2, x plus 3, but we're missing the x plus 2. And then we subtract, and here we have the x minus 1. And then from this term, we have x plus 2, x plus 3, so we're missing the x plus 1. So now what we need to do is we need to expand them and combine. So here we have 2x squared plus 4x minus 2x minus 4, and then minus, and I'll just expand it all out. We can see that this is really the difference of two squares, but if you don't see that right away, you can just realize x squared plus x minus 1, and these two cancel out. And then I'm just going to do squiggly line here because it just repeats that the denominator is x plus 1, x plus 2, x plus 3. So now I'm going to combine all of these. So I end up with 2x squared plus 4x minus 2x minus 4 minus x plus 1 all over and then when I combine them, I get x squared plus 2x minus 3 all over x plus 1, x plus 2, x plus 3. And now I have to factor that, so I end up with x plus 3, x minus 1 all over x plus 1, x plus 2, x plus 3. And I see here that the x plus 3's cancel out. So now I'm left with, on the top, x minus 1 all over x plus 1, x plus 2. And that would be my final answer. Of course, I can expand that out, and that's all fine, well and good, but you can just leave it as it is because I don't think it would help any to expand it. So now let's look back at the PowerPoint, which is done slightly differently than I did it here, and examine that the way I did it there. So here in example number 7, I work it out on the PowerPoint, and I look for the lowest common denominator, and I found the lowest common denominator is x plus 1, x plus 2, x plus 3, and then I look for, in each of the numerators, what's missing from the original numerator and multiply it by that. And similarly here, where I find for the first term, what's missing from here is the x plus 2. So I multiply the numerator by x plus 2. And then, of course, I have the denominator, which is my lowest common denominator, minus. And then I look for the similarly for here, and I have the x plus 2 that is missing from here, and I multiply it. And as you see, now I have both the same. The denominators are the same. I now multiply through. Now I have the two terms in the numerator that I could combine. And there I go. I subtract them and factor and find that I can factor out these two, and then I reduce accordingly, and I get the same answer, but written much neater that I did on the whiteboard. In example number 8, we're asked to combine these two terms. Now this one I'm also going to work out in detail on the whiteboard and then show you how I do it on the PowerPoint. All right, so for example number 8, let's look at the whiteboard. We have x squared over x minus 7 plus 6x plus 7 over 7 minus x. Now, we went over something very similar to this where they look very similar, but they're not. They look the same, but they're not. So let's look up. So one of the denominators in the first term, let's make this, one of the denominators in the first term is x minus 7. And then in the second term, the denominator is 7 minus x. Well, this one will keep the same, but this one, we have to pull out the -1 to get -7 plus x, and then we rearrange it, x minus 7. So for our first term, we have x minus 7, and then our second term is really -1 minus 7. So we can put in our denominator here, we can put -1, because this first one, -1, x minus 7. So this first term, as we see, lacks the -1. So we'll put -1 times x squared. And in the second term, well, we have everything that we need. So we just rewrite the second term. So now we want to put it together. So we end up getting negative x squared plus 6x plus 7 all over -1 times x minus 7. Now, we don't like to factor things with a negative sign. So what I'm going to do is I'm going to pull out -1 from the numerator here. So I'll get -1 x squared minus 6x minus 7. And then on the bottom here, I'll have -1 x minus 7. So that makes things very convenient because now we can just cross out the -1s, cancel out, because -1 over -1 gives us just 1. And now we have x squared minus 6x minus 7 all over x minus 7. So now we want to factor the top, and we get, when we factor it, x minus 7, x plus 1, all over x minus 7, and all we have to do is cancel those out, and now we're left with x plus 1, which is our final answer. So here I have example number 8 that now I'm going to show you how I do it on the PowerPoint, where I pretty much do the same thing because I realize that these two are opposites. So I'm going to pull out the -1 like I did on the whiteboard, and then I work it out and I work it through, factoring the numerator, and I see now that I have the x minus 7 and the x minus 7 cancel out. So there I am left with the x plus 1, just like I had on the whiteboard. Now in example number 9, I have this over here. I have just the 2 over here. So again, I'm going to work it out on the whiteboard, probably in greater detail than I did in here in the PowerPoint. So let's see what I did on the whiteboard. So in example number 9, we have 2, which I'll write over 1 to make it much clearer and easier to understand. 9, and the denominator here is 3x plus 1. So we see that the lowest common denominator here is equal to 1 times 3x plus 1. But we don't usually write the 1, we just write 3x plus 1. So we have the lowest common denominator is 3x plus 1. And we see that the 2 is lacking that entire 3x plus 1. So we write 2 times 3x plus 1. And then minus 9, since the term, the minus 9 has 3x plus 1 in the denominator, we just write minus 9. Now we want to expand this top part, so we end up with 6x plus 2 minus 9 all over 3x plus 1. And then we combine terms to get 6x minus 7 all over 3x plus 1. And we're finished because this is all we can do without killing kittens. Working out number 9, I find that the lowest common denominator is 3x plus 1. Remember, this is just over 1, just like I did on the whiteboard. So here I did that on the whiteboard to keep things clear and tidy so that I know what my lowest common denominator is. And then, of course, I proceeded to make sure that the denominators in both of my terms were the same. And then, of course, I combined the numerator, and then the numerator, and saw there wasn't anything I could cancel out without killing kittens. Remember, you do not want to cancel out things unless they're properly factored. In number 10, I have something very similar, so I'm now going to subtract off the 3, because subtract the following rational expressions. So this means I have this minus 3, and that essentially is 3 over 1. So I put it as 3 over 1 to keep things very clear. And then, of course, looked for, just like I did in example number 9, the same denominator, but I had to multiply the 3 times 2x minus 3, and then, of course, combine to get my final answer. So now I'm going to add these two expressions, so I'm just going to rewrite them as addition, and then I'm going to show you it on the whiteboard. So let's go over to the whiteboard and see how I do this particular example. In example number 11, we write 4 over x squared minus x minus 6 plus, I'll put a bracket around it so we know which term it belongs to, and then there's x squared plus 5x plus 6 and now we want to find the lowest common denominator, so we look at the denominator and factor the denominator in the first term. X squared minus x minus 6 is equal to x minus 3 x plus 2, and then for our second term, the denominator there, we factor, and we have x squared plus 5x plus 6 is equal to x plus 3 x plus 2. So we notice, so now we find the lowest common denominator, so we have the x minus 3 and the x plus 2.
from the first term. And we see we have for the second term, we have the x plus 3 because it doesn't exist in the first term. But the second term here, they're in both, and they're both to the same power. So we took the highest power, but since they're the same power, we already have them. So this is our lowest common denominator. So now we write on the bottom x plus 2, x plus 3, x minus 3. So we have our denominator. Now for our first term, we have 4. So we look at the denominator in our first term and we see what is here that's missing here, and we see that it's the x plus 3 term. And then similarly for the next term, we have x, and what was missing from that term? Well, we have the x minus 3. So now we multiply through the two parts, 4x plus 12, and then plus x squared minus 3x, all over the same thing, x plus 2, x plus 3, x minus 3. So that's equal to, so we're going to, we have 4x plus 12 plus x squared minus 3x. So we'll just rearrange it a little bit over the same thing. So I'll put the x squared first, and then I'll combine my two x terms here to get plus x. And then I have left is my 12. All over x plus 2, x plus 3, x minus 3. Now it turns out that we can't factor the top term. So that's all we can do. And sometimes it happens that we cannot factor all the terms. There's nothing we can do with that. So we're sort of stuck, and that would be our final answer.
Back to the PowerPoint, we added up these two rational expressions, just like I did on the whiteboard. I factored these out, and I used that to find the lowest common denominator, which is, here's the lowest common denominator, x minus 3, x plus 2, x plus 3, and then I proceeded to look for the ones that were missing from the original here. So here we have x minus 3, x plus 2, but it's missing x plus 3, so I must multiply by the 4 by x plus 3. And similarly for x, but what this particular term is missing is the x minus 3 term, because as you see it's not here, so I have to multiply x by x minus 3, and then I can combine them since now they both have the same denominators, and I use the distributive property to work these out and then finally combine it, and there is my final answer, just like I had on the whiteboard. Thank you very much. Be well, take care, and goodbye for now.